Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and lots of other interesting things. Your hosts today are Kem Raj and Cliff Brake. Hi, Kem. How are you?
Hey, Cliff, I'm great. I'm doing fine. How about yourself?
Yeah, doing well. Another great week. So, looking forward to learning lots about BSPs and discussing our experiences.
Sure.
Because really, this is what we do. We get software running on devices, and so maybe we could start out with what is a BSP?
Right. BSP is an acronym for Board Support Package. And in embedded Linux context, BSPs are very important because we run many embedded Linux on different devices, different single board computers or SOMs or other kind of devices. Unlike any desktop or server operating systems, are pretty much BSPs are common because your board is pretty much specified. But in this case, we may have different architectures, different peripherals on them, different kind of buses, and so what happens is BSP then is a layer, if you will, in the software stack, which separates all the details for bringing up the board to the applications. And that piece of the platform software is roughly classified as the board support package software.
Right. Okay. Yeah, that's a nice overview. So the board support package, or the BSP, just kind of abstracts maybe the hardware from the application layer, if you will.
That's right. Exactly.
Yeah. Okay. So maybe it would be helpful to just go over at a high level what are some of the pieces of a BSP, just to get an idea what's in there.
Right. I think, as you know, BSPs essentially, as we talked about, is the software that is closer to the hardware. So if you start from instruction 0, you have your boot ROM, which is essentially programmed into the chip itself. But then once boot ROM starts, the first thing it transfers control to is some sort of first line software. You can call it like first stage bootloader or something of that name. But overall, this is your bootloader, which essentially initializes the hardware, your memories, and make sure that enough of hardware is initialized, and then it transfers the control to a higher level software, which is the Linux kernel. And then Linux kernel takes the control over. It then initializes the full system, including any peripherals or any GPUs or any other kind of devices you have in them, which then, Linux has the driver concept, which means, every device that is in there will have its driver. It will have a technique to detect it, initialize it using the driver. And then these drivers could actually be either inbuilt into Linux, which is like, part of the Linux kernel itself, or these drivers could be provided by, the device manufacturers, and, which could be considered as external driver. And so all that comes together and brings up your system up. And in addition to that, you also, these are like primarily I would consider as major components in a typical embedded Linux BSP, but it's not limited to that, because if you have FPGAs, there will be FPGA programming tools, or there would be like bitstream generators, and they are also specific to these chip that you're working on, so they also become part of the BSP.
Sure. Right.
And yeah.
So there's quite a few pieces of a BSP. Where do BSPs, you mentioned like a processor vendor may provide a BSP, but I'd like to kind of discuss, where do BSPs come from, who uses BSPs, and just kind of understand the workflow when creating a product,
Right.
How BSPs fit into that.
Yeah, very good question, actually. I'll take like in the background of Yocto project, because that's what we use in our daily lives. Typically, even other infrastructures that build embedded Linux-based systems, they have similar setups. So there will be a lot of similarities that non-Yocto users can also relate to. And so in Yocto, what you will see is it has a layered architecture. So you have your core layer, which basically provides you all the tools, compilers, and core set of libraries and so on. And then it basically separates out the board support pieces out into a separate layer of its own. So you are really you can basically write your board support package software as an overlay in some common speak. In Yocto speak, that is called a layer. What then happens is if you add that layer to your layer mix, like a layer of a cake, and you have a new flavor, and that is your BSP adds to the flavor. So to give you an example, say if you were to build for Raspberry Pi, you check out Yocto project, and you may not find Raspberry Pi as a default machine in there as part of your core metadata, because the core only has QEMU based like emulator machines, and that's all, and maybe some reference boards probably. But then what you do is there is a separate layer, which means a separate Git repository, which adds all the board support pieces for Raspberry Pi based machines. So you check that layer out, and then you add it to your project. And then now you have all the Raspberry Pi machines available to you. And this is the fundamental process that is used by then all different kind of machines that you would want to build for. The beauty of this process is that many times you might be just interested in dealing with one kind of machines, right? So you want to have, say, just Raspberry Pi based machines because you only deal with Raspberry Pi 4 or Raspberry Pi 0 or something like that, and you really don't worry about others. So that's the only layer you take. Unlike some other places where you might have hundreds of machines in there, and then you confuse yourself. So there's an advantage to that, and it gives you that combination to pick from. And you can also have multi-BSP setup. Like if you look at your distribution, it has multi-BSP setup because we build for some Freescale CPUs, some Raspberry Pi, or some other Atmel and now Microchip based BSPs. So you could have that a subset of BSPs added to your distribution. So you can build multiple CPUs.
So Yocto provides a very modular approach where you just pull in layers for the particular processors you need as BSP layers. Yeah, and that's kind of neat because then you can have one Yocto tree that supports several different products that may use several different processors.
Yeah,
you don't have hundreds of processors kind of polluting your build system, or maybe I should say just making it kind of crowded or whatever. So
yeah. But there is a note of caution there, though. What happens there is that a lot of these BSPs you asked earlier, who maintains them, and so they are written by the SOC vendors themselves. And of course, it's available to you on GitHub or some other, mechanism. But they do not test it in combination with another BSP.
Right.
So you might say, I need Meta Raspberry Pi, and I also need Meta Rock chip. But that combination, when you put it together, may infect each other in some different ways. And we'll talk about it, what those are. But essentially, that should not happen as per Yocto project design. But invariably, it does happen, and it's something, a note of caution.
Yeah, so that's where a monolithic tree like Buildroot, where everything's in one tree, you would have less chance that you'd have clashes then between.
Yeah.
So those are trade-offs, right?
Right.
So this brings to mind like a little more complex scenario. We use a lot of Verisite system on module, little boards that we plug into a baseboard. And a lot of these use Freescale processors. I guess that's NXP now.
Yeah.
So it's interesting that one of those setups would have the Meta Freescale BSP layer, and then it would also have a Meta Verisite layer that builds upon top the Freescale BSP to add some additional tweaks, for their SOM modules. So BSPs can have multiple levels of people adding stuff to them to support all the hardware that may be available.
Yeah, I think that's a very good point. And I see it in a little bit, a little bit this way, that you have your final boards, or some sort of SOMs you mentioned, and then you have a what you can call like SoC, a system on chip, which is kind of a relation you can have. Like you have a full chip with everything defined that can go into a product, and then you have the base architecture, which could be IMX, or which could be similarly some other Exynos or something like that. So someone like NXP would support their reference boards, right? Which will be a IMX6, IMX8, IMX7, like that. And they will support their reference boards, but that's not something you're deploying in your real products. It's actually just the SoC that is sitting on those. So you will still need to make sure that your product that you're designing, all the tweaks or differences it has to the standard board from NXP is handled properly. And with Verisite, it is in the similar fashion, where either you can consider it as this is your final like a device, or it is kind of based on a particular SOC, kind of a derivative of a SOC.
Yeah, just to recap a few things. A BSP, maybe the main pieces would be a U-boot recipe and a kernel recipe. So I often tell people that if you have a good U-boot kernel, good U-boot and good kernel sources for a particular piece of hardware, it's relatively straightforward to pull it into Yocto, because those really abstract the hardware pretty well. And if you have those two pieces, you can usually build up a decent board support package in Yocto. Of course, there's more other pieces that we can talk about in a little bit, but that's the basics.
Yeah, that's fairly basic, I think, that you would need. And it could be a bootloader of your choice. Say if you're not using U-boot for whatever reason, it could be a different bootloader. Yocto doesn't bind you to one or another. However, if you are using something like U-boot, then there is a lot of support for U-boot in core Yocto, in terms of creating fit images, or the way because U-boot is open source, so a lot of contributors are helping there to make sure that all those pieces are intact, and so there is an advantage of doing that. So you would see that there is a abstraction, a U-boot class, that basically will give you all this services if you have a U-boot based bootloader.
Right. So Yocto has a lot of pieces that help us, pieces that we can leverage for many different U-boot and kernel recipes. So yeah, that's good. Right. So just thinking about this, there's probably a lot more people that use BSPs than create BSPs, I would assume, because most BSPs, the bulk of the work is done by the system on chip vendor, whether it be Broadcom or Freescale or whoever. So then there's a whole bunch more people out there that actually use these BSPs to create products based on these processors. So just thinking from the user perspective, what do we need in a BSP, or what helps us use a BSP?
So it's a good question, and it's very subjective at that point, where it depends upon users quite a bit too. Some users are top-level users. So to give you an example, they are writing applications or writing a sensor system, or they just want to access video resources on a Raspberry Pi, and they really don't care, which kernel version it is, or what kind of other part of the systems there are. For them, it's very important that BSP works out of the box, boots the system, gets them onto the if it is a graphical system, then gets them to the graphical system or console or what have you. For them, it should appear like a PC, like they have, as if they were accessing any Linux system, like a desktop system. If anything changes there, they get very confused.
Yeah.
And so that's basically a bad mark on BSP at that point. That, hey, a simple example could be, what are your default graphics drivers, right? So again, I'll pick on Raspberry Pi. It has like a closed source userland graphics driver, or it has a Mesa-based V3D driver. So now it's up to the BSP to give you an option that is your default, right? They may test both, they may try both, but then which one do you offer as a default will also have an impression on your BSP's quality in minds of such users. Then there's another set of users who basically want to enhance it, which means that they might add a hat or a peripheral that they need to add a few tweaks to enable it onto the base BSP. They are looking for documentation, right? So they are looking for, how do I do this, right? How do I maybe change the default configuration for the kernel to enable additional drivers? Or they may say, how do I enable I2C? Or is there any settings that I have to do in bootloader to disable, enable some GPIO pins? Or do I have to write a additional device tree overlay? What are the ways that the BSP exposes itself to its I would call them more like a BSP developer users. So they are like more like power users at that point.
Right.
See, the other users of BSPs are distribution builders. So distribution builders are looking for, how common are you with other BSPs, in terms of, do you support, what kind of file systems do you support, or what kind of graphic systems do you support, and what kind of init systems will work on you. And so they are looking at those aspects of the system, which are more like, at a policy level, they are defined as distribution features, but at certain point they intersect with the machine features that board will have.
Sure. So that's very interesting to think about three different types of users. And from my perspective, where I've spent most of my time building products based on embedded Linux, we spend most of our time at the application and user space level when we're building a product. The BSP, it's best if that just works and really gets out of our way, and it kind of becomes invisible. So after we might tweak a few GPIO settings in the device tree. We might change the kernel config, but typically that's kind of the standard stuff. We might add a custom Linux driver, kernel driver. So those are the types of BSP modifications I typically see when we're building product. But again, that's only a small piece of the total development effort. So I think it's really important for BSP vendors to understand that they're just a small piece in this stack of software required to make a product.
Absolutely.
And I think sometimes BSP vendors maybe don't keep the user needs first in their mind and kind of get that backwards and kind of think the BSP is the main part of the system. But really, people building products, they're not spending a lot of time in the BSP. That's just kind of a necessary piece that we build on top of.
Yeah, that's the key piece you said at the very end, that it's a key piece that you need to have, and it's not the crown jewel at that point of time. That if you look at the final products that people are kind of putting out there, then it's an enabler for them. So if you are writing a BSP, that is the correct mindset to have. It's
Right.
about enabling your customers to use your chips in best possible ways.
Mm-hmm.
And it could be that, say, you have a certain hardware piece, how best you can expose it to the user, how easily the user can use it. That is the key piece for a BSP maintainer. So you
Yeah.
can have a library underneath and then expose that through interfaces. And all the detail and all the beauty of your code and optimized version of your code could live in that library. And that's totally fine. But
Mm-hmm.
you have to think from the user's perspective that is the end user going to benefit from it? Or are you creating something that's going to be a step aside for the developer and then
Sure.
use your BSP. So a typical example I can give is there are these standard interfaces for OpenGL, for example. So yeah, you might have some nice implementation in your GPU that would give them additional benefits, but then it'll be important that you comply to the OpenGL specifications to expose those interfaces rather than invent your own and then ask developers to program for that, for example. So standardize where it can, use those standards to expose, your BSP's bells and whistles rather than inventing your own. And that's very, very important because you might be having an user who is coming from a legacy of applications that have been working on something else. And the chances of it being on, say, some sort of OpenGL are very high. So it makes their life so easy. And they will love your BSPs because, they say, hey, I didn't do much work, and it just worked here.
Yeah. Yeah, that's an excellent example. And as we kind of think about the qualities of good BSPs and the experiences we've had,
Mm-hmm.
one thing that really comes to mind is a BSP should be able to stand alone. You should be able to take that Meta whatever, Meta Freescale or Meta Raspberry Pi or Meta AM Logic or whatever your BSP supports. You should be able to drop that into any Yocto build,
Mm-hmm.
and it should pretty much work without a lot of extra stuff around it required to prop up this BSP.
Right.
And what that does is it allows your BSP to easily plug into your customer's build system, how they choose to set it up.
Yeah.
Because again, your BSP is just one piece, and your customer may be using several BSPs
Mm-hmm.
in their development. And
Yeah.
one thing I see in some of these BSPs is they try to provide the whole Yocto build. They kind of come up with what they think is a better way to do Yocto builds, but details of the BSP then leak out into maybe the entire build, where the BSP requires special files to be generated and so on.
Right.
And then this makes it very difficult to apply that BSP into an existing Yocto build system.
That's an excellent point. Very, very good point. And you rightly mentioned where the end user might be building a product that is using multiple BSP. And that's a very common setup. I can certify to that. I've worked in many companies, and that has been always the case. In one of the products, we had a BSP based on PowerPC, a MIPS, and x86, all three systems going into a same system, right?
Wow. Mm-hmm.
So now you can think of this, you're building like 3 different images or maybe 4 different images. In fact, if depending upon what kind of line card you have, you might have a different SoC on it. So now when you are building a software for this whole system, you are building not one, but all of them together, right? So you have multiple images that you're building together. So one of the things that they use Yocto for is this horizontal scale, because they say, hey, I can use same tooling to give me this complex firmware system put together. And now if you say, no, here is our SDK, which is basically whole Yocto bundled into something.
Right.
Then I have seen some of the end users build this differently. They are building like 4, 5 different kind of Yocto builds, and then cobbling up their own system on top to basically extract the images and then do something that they have to do for their final packaging and so on. So it's a very clunky system, and their engineers are very sad because think from their perspective, right? So they
Yeah.
have written a piece of software in the middle which needs to be tested on each one of them. In many cases, you are lucky if your software is only meant for one line card or something, then you can just stay there and test it out. But think of if it is to sit on all the systems, how does that test work? It's very complex. So as a BSP writer, it's very important for you to realize your place in that kind of ecosystem and add value there. I can think today if a BSP owner comes in and says, "Yeah, my BSP is a multi-tenancy friendly, so you can have another BSP in here. I know that my BSP will work." We test that kind of scenario, and they may not test it with all the zillion BSPs out there, but as long as they test it with one or two, 99% of issues are handled.
Right.
So if they can ensure that to their end user and say, yes, we do have a distribution, for our own internal testing, but in order for you to put together, you could take our layer, or our BSP layer, stitch it into like Yocto release, whatever, right, to 3.1 or what have you, and what comes out will be exactly what we can support you on.
Right. Yeah, that's excellent. Spoken from the voice of experience, working on many different products and and maintaining a lot of the Yocto stuff. So yeah, that's real good. So one other thing I really appreciate when vendors provide BSPs is they also provide Git repos for their U-boot and Linux kernel source. And that way, if we have to tweak the Linux kernel source, we can fork their Linux kernel, their U-boot source. We can make our tweaks and then just tweak the recipes in the BSP to simply point at our repos instead of the vendor's repos or even upstream repos. And then that makes it very easy for us to customize the BSP. What we don't want to see is like one thing I've run into recently is a vendor providing Yocto support in the form of a huge tarball that you download, and it has like everything in it. And they don't have Git repos, public Git repos set up for their Linux and U-boot sources. So then you have to dig through this, 10 gigabyte or 20 gigabyte tarball of like a Yocto build someone scraped off their workstation and try to find the Linux sources and then figure out how to get them back into Git so you can maintain your changes on top of them.
Right.
And that really makes it hard. And I know BSP vendors have good intentions and they think they're making it easy by providing the whole thing as a canned build. And some of them have even told me they're trying to reduce their support costs because if everyone's setting things up from scratch, some of the support can come back on the BSP vendor.
Yeah, I think that's true. What I think is that by providing shared history of your sources is actually making your life a lot easier than you would think when it comes to supporting you or when it comes to supporting your customer, because especially with Git, there is a lot of history that is, in say, take an example of, say, you were sharing your kernel tree as Git repository. And so the end user would be able to look through and then say, do I have this fix already? Or do I don't have this fix already?
Exactly.
They can basically, the support that will come back to you will be a quality support, which means they will come back to you informed about this is the issue that I need to solve and I need your help. Rather than, if you give them a blob, they'll give you a blob back. And that's going to be, too much of to and fro and, not an happy relation in the end, because the problem will be solved in the end one way or another, but it's the experience of solving the problem that will be left aftertaste. And that will continue your business relations or other things, in future. And it's very important to have that piece to be more plausible.
Yes, that's an excellent point. Yeah, these are all great thoughts, and we should really probably put this together as like a summary blog post or something. But
Mm-hmm.
so, what
Yeah,
are some Go ahead. I'm sorry.
yeah. So I was thinking that we do have our handbook that we publish for that you have started actually, and it
Hmm.
could be a part of our handbook as well,
Sure.
as part of a standard chapter on BSP development or something like that.
Yeah, Yocto BSP best practices or something. Yeah. So, what are some examples of platforms that have good BSPs? Ones that you've seen that are well done and easy to integrate into multiple
Hmm.
different systems. And
Yeah. So I think I wouldn't kind of like call out many names out there with good or bad, but few of those that integrate well are the key pieces that we look for. Is I work with Meta Raspberry Pi, and it's always a pleasant experience to work with Meta Raspberry Pi for
sure.
two reasons. One is that it always builds, and
Hmm.
if there's a build failure, more often than not, it is something else. It's not Meta Raspberry Pi's problem.
Yeah. Hmm.
So, that's a very good experience to have when, you're doing something like that. So I highly appreciate the amount of effort that Meta Raspberry Pi puts in to make sure, the pieces are moving in tandem. The other aspect of Raspberry Pi is that, it can fit into multiple BSP setup. So
Yes.
and it's very important also because nowadays people start with Raspberry Pi, right, and they do their experiments, and they say, yeah, and now I can go and build my real product.
Mhm.
So but they still want to keep Raspberry Pi builds and Raspberry Pi implementation going because it's so easy for them to continue as a development platform.
Right.
So it's an easy way for them to transition to something else that, maybe a custom chip that they're building and everything, but then they can keep the Raspberry Pi attached to it and then they can do all their validations. So it's very important for them to live in a multi-BSP environment. And I think the other thing they do really well is they use this concept of dynamic layers. So what happens is, in many cases, there are certain pieces of the software from user space like GStreamer or others, where invariably you will have some SOC-specific plugins or SOC-specific optimizations. And GStreamer is a generic framework, but then how do you make sure that the pieces that you want to, provide like optimized versions or maybe enable certain things for just Raspberry Pi? How do you do that effectively so that you really don't touch other pieces out there? So
Hmm.
they manage that quite beautifully using dynamic layers and using the Raspberry Pi specific overrides. So for example, say GStreamer has enable Raspberry Pi plugin support or something, which will enable the nice codecs and everything underneath. They will enable it when you use Raspberry Pi, right? So they will not enable it otherwise. So what happens is if you're building for, say, Freescale something, then it doesn't inject itself in there. But when you're building for RPi 3 or RPi 4, then you will get those changes built in.
I see. So that's very interesting because we've had experiences in the past where one BSP layer will globally modify files
Hmm.
and then mess up another BSP. So occasionally we'll see a clash, but it sounds like the Raspberry Pi layer has really done this nicely so you don't get clashes between BSPs.
Yeah, exactly. And that's very
Okay.
important to understand your place that we were talking about earlier, that yes,
Mhm.
we have to live together, with other citizens of the society.
These are universal concepts, aren't they?
They
It's
are
we have to get
indeed.
along.
Yep. So yeah, I think there are many others, and I think Meta Atmel, which is they started with Atmel and then is Microchip now. They also do a very good job. Although they have come along a long way. So one of the aspects that you would find with BSP layers was that they would take a release and their master would be following that release. So they would take a Yocto release and then treat their layer their layer's master working with this release as golden. But what happens is development moves to the master in Yocto, right? And then so they would say, well, use same master of their layer with both of them. Doesn't work nicely. I mean, it does work to a certain extent, but you have to put effort to it. So they were like very in that mode for some time before they started maintaining master. So it's highly recommended that, if you're a BSP writer, then always follow the trunk. And then whenever there's a release made, maybe tag your BSP or create a branch for your BSP, however you want. But it's absolutely key that you follow the master.
Yes, that's good, and I, like you said, to create tags and branches, that's nice as well, so that people can check out the correct version of your BSP for whatever version of Yocto they're using.
Mm-hmm.
So both of those things are very key to having a BSP that's friendly to use. And
mm-hmm. And on the other side, I've seen some BSPs where they have like distribution policies as part of the BSP.
Sure, right.
They have many different layers underneath, which are doing iffy things with common packages. Again, they are doing it good for themselves where they are separating those under sub layers, but they are making it harder for their end users because they may be using multiple layers and your common layer will conflict with the other BSP. So a recommendation I have there is that always have a test scenario where you bring in another BSP layer and build their images and see whether there is anything wrong happening.
And like you said, the Meta Raspberry Pi is a good one to pull into your test builds and just make sure everybody's happy. Yeah.
Yeah, and I think the one other issue that usually falls under BSP, you would say to a certain extent, is or we have seen is packaging. Because what happens is mostly your memory maps are kind of, or sample memory maps, templates are designed by the SOC vendors for their reference platforms, and then real product guys kind of build upon top of that, and then they start using that. And so what you end up doing is you end up creating this custom create SD card or whatnot, and that script. I recommend to use the Wick, which is the Yocto's image creator. So instead of going towards this approach where you want to build some write your own class or write your own script or what have you to generate these images, see whether you can leverage Wick, for example, creating your final image. You will be commonly known technology. B, it's a lot less work because Wick is all maintained by Yocto project. Right, so you will just maintain your Wick, image recipe rather, your Wick template, and then you'll be good to go.
Yeah, that's an excellent point, and I would suggest that anytime you find yourself writing scripts in a BSP, like outside the context of a traditional recipe or traditional Yocto tooling, you need to really think hard about that. Is this really necessary? Because what you're doing is implementing a non-standard piece of the build that will be very difficult for people to use your BSP then without doing a lot of digging and debugging. And these scripts, they start simple and they seem kind of innocuous, but I've been through this enough times where it's just never pleasant. So.
And one bad thing that I've seen in some cases is they fork major components.
Oh,
so we talked about kernel and bootloader, and that's great. You fork them, and they're specific to your BSP. But there is no point of forking GStreamer. There is no point of forking GCC for that matter.
Right.
So there are examples where the tool chain is also forked in BSPs, and those are really bad settings in my opinion. To start off. So.
Good point.
And another thing that I saw, and I think as a maintainer of MetaRes 5, I follow that too, is pose upstream, right? So see how can I get rid of this from my layer. So a typical example is, say, we have to carry a patch for kernel to support RISC-V 32-bit. So I would start reaching out to, Linux Yocto maintainer and say, hey, can you take this patch? And then if, the Linux Yocto maintainer says, yeah, fine, I can take it, I will just happily give it to him and then, remove it from my layer. And that's probably, throughout the RISC-V community, but at least in here, we take those patches and we send them to the respective upstreams, whether it is the kernel or is it U-boot or any other component. You don't want to home the project's, patches in here, always posing upstream. And they may reject it. They may say, not now, maybe later. And, so we still have patches in there, but that's not their permanent place. So that mindset is very important. I think it's very helpful where, you're looking at and you're asking, why is this GDB patch still here?
Yeah.
Can I send it upstream? And you see that next day they apply it. Mm-hmm. And, you have gotten rid of one patch that you're doing in or something like that. So I also look at the quality of the layer by looking at number of patches that they're carrying.
Yeah. Small is good, right? I mean, it's kind of counterintuitive, but the less stuff you have in a BSP layer, that means the maintainers have been doing a good job of pushing stuff upstream. And, that takes a little more work short term, but long term, you're pushing loads of work off on other people, and that's really better for everyone. So,
and it invites it invites a lot more users, whether you notice it or not. But when your changes are moving upstream, that becomes more common to a larger set of people. So as a result, you have a good chance of building your community a bit better and get more users by doing this.
Sure. This has been a lot of great ideas. Anything else that comes to mind, Kim, about BSPs? And
yeah, I think BSPs are key, in a sense, and it's very, very important that these BSPs are well oiled, and more importantly, they are easy to integrate.
Yeah.
In end user settings in different distributions. Yocto project has a program where you can get the badges for Yocto compatible. The program actually has certain test suites that you can run on your BSP, and I would think that's a good starting point for a BSP layer to introspect and see how they are doing. It may not be covering all the things that we talked about, but it will give you a good set of things to work on, to make your BSP a high quality and high class.
Excellent. Very good. And I'll put in one more plug for the Yo distribution. We carry quite a few different BSPs in the Yo distribution, and we sometimes have to do a little extra work to make them play together. But if you have a BSP and you want a good distribution to support your BSP, consider the Yo distribution. A lot of good ideas there, and it's meant to contains all this knowledge we've learned over many years. Could be a help to your BSP and make it easier to use for your customers.
Absolutely, yes. Your distribution, way to go. And we actually helped a lot of these BSPs to become multi-tenant.
Sure. This has been a great discussion, and if you would like to discuss these ideas more, feel free to visit our community over at tempdir.org or contact us directly or on the GitHub projects. We would welcome feedback or any communication. Anything else today, Kim?
No, it was a great discussion, and I think if listeners want to hear more, we can do Yocto BSP Part 2.
Yes, there's lots more we can talk about. So, yeah. Okay. Well, until next time, take care.
Take care.